Hi, this is Amin, and in this video I'm going to talk about MPLS, Multiprotocol Layer Switching. So what is that? Imagine the crowded network like that, and what you want for your routing. For example, you are here at HA and you would like to send something via this greenway to HF. What will happen? In your packet, in the header of your packet, you have source and destination, either for MAC or your IP. And at each router, the packet will be open, and we have CRC check for the security of the packet, and then changing the header, and I mean source and destination, and then it goes towards it. So as long as we have lots of routers in our way, it will be time consuming, and in the past, due to not having good CPUs on the routers, so it was more time consuming. What they've done, they thought about in the way that there's no need to go towards layer 3. Maybe on layer 2 we can assign a label to our packet, and they're gonna just check the label and forward the packets. This is the concept of MPLS. So for crowded networks, we can just add a label to our data. But in order to verify and show you the configuration, let's come here. I've set up this network, but I didn't think anything else. Here we're going to do an OSPF area 10, maybe would be good. So MPLS, on the whole, it is in IS routing protocol or OSPF. On these two routes, we can have MPLS, and the configuration is pretty easy, but just we should learn the concept, and at the end with the commands of show IP, show MPLS pack forwarding, we'll see that and we'll understand that. But at first, look, these are the networks, and these are the IP addresses, for example, 12.1.1.1, 12.1.1.2, and the same. All of the interfaces are set up, the loopbacks and also the computers. So I'm going to run OSPF and show you those OSPF configuration as well, and then just adding MPLS. So let's go to the PuTTY. This is the PuTTY, and yeah, I've just, look, we can verify that we have 12.1.1.1, 192.168.0.10, and 1.1.1. So what do we need? Just go to the router, OSPF 10, like adjacency changes, router ID 1.1.1.1, and just add the networks 1.1.1.1. I would like to ping all of the networks, so I'm gonna add my loopbacks 0.0.0.0, and the area would be 0. So the second network will be 192.168.0.0, and the mask would be 0.0.0.255, and finally the last network will be 12.1.1, and yep, it's okay. So we have OSPF here, and also we can add area, OSPF 10, area 0. So let's come back to the PuTTY. So OSPF 10, just this. We can come to the R2, go to router, OSPF 10, like adjacency changes, the router ID is 2.2.2.2, and also we can verify all of the networks here. So the first network is 2.2.2.2, and the subnet is 0.0.0, and the area would be 0, and then the other network is 13.1.1.1.0 and 0.0.0.255, and the area is 0, and also we can copy the 12 network from here and paste that here. So good. Look, there's one adjacency here. And then go to the router OSPF 10, So go for the networks. I have this kind of loop back, these two interfaces. So network 3333.0.0.0.0, and the area 0, and then network 14.1.1.0.0.0.255, and the area is 0. And for 13, I can just come here and copy that one, come here and copy that one, log adjacency changes, the router ID is 3.3.3.3, and I think, yeah, we're done now. And finally on 4, so router OSPF 100, network, for example, what do we have? We have these networks. So 4.4.4.4.0.0.0.0 and area 0. The other network is 172.21.16.0.0.0.0.255, and the area is 0. And for 14 network, I'm gonna come here and just copy that one and paste it here. So we should see like adjacency. And yeah, let me add that again. And the router ID is 4.4.4.4. So we can write everything on each router. Do write. Let's do write and do write. So how to check? We have PC1. I've set up this IP address on that 192.168.10/2400. Go to PC2 and type IP 172.16.21.10/24 with the gateway of 172.16.21.100. And now we should be able to ping the other computer 192.168.0.10. If OSPF runs correctly, we should be able to ping. So there's a, let me do it again, and in the meanwhile, check. So do ping, for example, 1.1.1.1. It's, oops, no, it's myself. So let's ping 192.168.0.10. Can we ping that? Yes. So let's ping everything with the source loopback 0. So loopback 0 can ping that one. So 2.2.2.2 we can ping. For 3.3.3.3 we can ping. For 4.4.4.4 we can ping, yep. And this one, yeah, this one is okay. It should be able to ping. I don't know what happened to that one, but anyway, we will work on that to see what is the problem. So do show, no, do show. Let's do some ping from that side. Do ping 172.16.21.100, my interface, the other computer, and I think all of them are good. Source loopback 0, and yes. So now let's think of the MPLS. But before that, let's realize what is the problem of pinging. And yeah, this is here. We can see that the network that I've added is incorrect. So I just copy that one and type no behind that, and then should be 16.21. Yep. And now it should be able to ping. Yep, yeah. So there is no need for the PCs because now the network is working. Just go for the MPLS. I'm gonna do just on one of them and copy and paste. The first thing on global mode, we do need to type MPLS and these are the options. MPLS, the first thing is label. So we do need a label. How we should look, it depends on how many networks that we're going to advertise. We're going to add a label to each one. So label, the first protocol, and LDP, layer distribution protocol. So we are saying use MPLS label protocol LDP and MPLS label range. We can come up with a range, and it is not important if the range of the R1 and R2 is the same. It should be unique inside one router. So range could be from 10 to 20, and hit the enter. Range, what is the problem? MPLS range, oops, from 16. So 20 to 30. And then let me see what else do we have. MPLS LDP and oops, router ID, and like what we've added router ID on OSPF, local force here. Loopback interface 0 force. So this is the only thing related to that one, and we go to, let's do show IP interface brief, which interfaces FA00 and gig0. So interface FA00 and IP MPLS IP, I think. MPLS IP. Let's copy that one. And interface GI10 and copy. Oops, MPLS IP. What's the problem? Interface GI10. Interface GI10. What's? I got confused. Go to the config terminal. Interface GI10. So MPLS IP. So that's good. That's okay. And go to the R4 MPLS. What else do we have? MPLS label range from 60, a number, to 90. MPLS label protocol LDP and MPLS LDP router ID, loopback 0 force, and let's go to the interfaces. Interface FA00, MPLS IP, and interface GI10, MPLS IP. That's it. Go here, MPLS. We can see the options. MPLS label range from number 100 to 120. MPLS label protocol LDP, MPLS LDP router ID. Router ID is loopback 0 and force. So that's it again. Interface FA00, MPLS IP, interface GI10, MPLS IP. It's okay. Come here, look. Same. There's a neighbor. There's a neighbor, there's a neighbor, there's a neighbor. And finally, here, exit. Let's, for everything right, the changes. So MPLS, and do we have MPLS label? Let's see. Mode protocol range. MPLS protocol, two protocols, LDP and TDP, but default is LDP. LDP, MPLS label What else? Range from 1999 to 1090, maybe. So we have at the range, we have the protocol and MPLS, LDP, router ID, loopback 0, and force. So interface FA00, MPLS IP, interface GI10, MPLS IP. Finished. For all of them, look, we had an and let's do in and right. We had live for all of them. So write memory. Now we can ping. I mean, before that we could ping, but let's see, ping .3 for the end of the path for that. But it is telling us if we trace for that, we can see it is going via MPLS label. And also if we show IP route, we'll see, look, yeah, we have C, we have O, we have L. We can see all of them. We have L connected, we have C local, and also we have what? We have OSPF, which is O. It is telling us all of them are connected. All of them are connected via OSPF or directly connected or something like that. There is no MPLS here. This is the first thing, because show IP route, it is for layer 3 connection. And layer 3 connection in MPLS scenarios is a support. OSPF or ISIS, these two are support to the MPLS to do the routing in layer 2, but they are necessary to be. But if we show MPLS neighbors, not neighbors, sorry, forwarding table, we'll see what it's saying. For example, from R1, we want to go to R4. What is the network 4.4.4.4? It is saying, look, I've mentioned the range, and also we can see show MPLS. Look, we have show MPLS flow, interfaces, IP, label, show MPLS label range. If we do show MPLS label range, it's saying your label range is from 20 to 30. Look, show MPLS and also show MPLS forwarding. It's better now. So my range is from 20 to 30. And so the label is started from 20 to 25. It depends on the networks that we have here. And it is saying, if you want to connect to this network, it's pop label. It means you are connected to that, which is router number 2. Or this network 13, there's no need to have a label. You have the connection. But if you want to go to 444, you have to search for this label, 62. Where is the 62 label? If you want to connect or if you want to share something to this network, you need to change your label from 22 to 62. So let's go to the next hop. First, let me go out this way. So, and right, show MPLS label range. It is from 60 to 90, and show MPLS forwarding from 60 to 90. And here it said if you want to go to 4444, let me highlight this one. If you want to go to 4444, you should search for 62, or you should go towards 62. And here we'll see where is 62. This is 62. If you want to go, so the packet comes from router 1 to the router 2, and router 2 is telling, okay, if you want to go to 444, you should change the label and go towards 100. Where's 100? Let's go to the next one. And first show MPLS, a label range from 100 to 102 and show MPLS forwarding. Look, here it said if you want to go to 4444, you should go to 102. And here the range is from 100 to 120, and 102 is this. So it comes here and said, okay, you would like to connect to 4444, it's pub label, it is the next hop of me. And look, it's better. So pub label, there's no outgoing label for that, it is the next hop. And here, and show MPLS label range from 999 1009 and show MPLS forwarding. So 444 network is here. Look, there's nothing here because we didn't mention that on the MPLS, I mean the interface. But anyway, it said you should go, if you want to go to this network, you should go to this interface, which is the next hub, and that one is here. So that's it. Everything is it. If you want to configure MPLS, it's pretty easy. Just you should mention 3 commands, the range, and you can use, you can just add MPLS autoconfig beneath your OSPF routing, and the router will do everything automatically for you. But to do management for better, or I don't know, easier troubleshooting, it is better you as the admin of the system assign everything to the system. So anyway, it was the video for the MPLS. I hope you enjoyed. If you enjoyed, show a thumbs up, hit down the like button, and don't forget to subscribe to the channel. Bye everyone, take care, bye.